Lesson 8, vertex form of a quadratic function. So vertex form is y equals a x minus p squared plus q. Your vertex is pq. Your stretch is a. So what stretch means is how far it goes up and down. So for the first equation, we have y equals 2x minus 3 squared minus 4. A is 2, p is 3, q is negative 4. Now notice, because we're looking at just p, ignore this negative sign. It's always going to be the opposite. If this said x plus 3, it'd be the same as x minus 3. So when it's just a negative sign, our p is positive. If it was a positive sign, our p would be negative. So we know our vertex is at 3 and 4, negative 4, sorry. And our stretch is 2. Now to understand stretch, if you thought of a normal y equals x squared function, if we plugged in x and y, if you plugged in a 0 for x, y would be 0. If you plugged in a 1 for x, y would be 2. Sorry, this is supposed to say 2x squared. So x squared would be 1 times 2 would be 2. So negative 1 would be 2 as well. If you plugged in a 2, 2 squared is 4 times 2 is 8. So everything is doubled. So when we draw our function, all we're going to do is we're going to draw the function as if it was stretched by 2, but once it's been moved to a new vertex. So we're going to move it to 3 and negative 4. So here's our vertex. So from this point, we're going to plot these points. So when you go over 1, you're going to go up 2. Same with when you go left 1, you're going to go up 2. So here's our axis of symmetry. When you go over 2, you go up 8. So 1, 2, 3, 4, 5, 6, 7, 8. If you go over 2, you go up 8. 1, 2, 3, 4, 5, 6, 7, 8. So what it's doing is it's been translated or moved over and down. So a normal x squared would be over here, up like this. But we've moved it to the right and down. So our function actually looks like this. So it's the same shape and it goes up by the same amount. It's just been moved. So when you graph it, the easiest thing to do is graph your vertex and then graph your stretch from that point. Okay, now what we're going to do is we're going to guess how many vertex or how many intercepts something has based on an equation. So all we're going to do is do a quick sketch. So first you need to know where the vertex is. So the vertex for this one is at 2, 5, P, Q. And I forgot the negative sign. Next, we're going to find our direction. So this one, because A is positive, means it opens up. I don't need to write open again. So if we were to do a quick sketch of this, our vertex would be 2 and negative 5, and it would open up. So that means it would cross the x-intercept, or it would have 2 x-intercepts, so there would be 2 solutions. So 2 intercepts. For the next one, our vertex is at 0 and 0. If there's no P and Q, it's just a 0. A is 1, so it opens up. So if it starts at 0 and 0 and opens up, it'll only touch the x-axis once. So there's 1 intercept. For the next one, our vertex is at, so because this is a positive, negative 3 and positive 4. And it opens, because this is positive, up. So if you plot your point at -3 and +4, it will never ever touch the x-axis, so there's 0 intercepts. For the next one, our vertex is at 2, -3, and it opens, because this is negative, down. So if you go to 2, -3, it would be down here, and it opens down. So this will never touch the x-axis, so we have 0 intercepts. So you can guess on an equation just based on looking at the vertex and your a value. So we're going to take a graph and we're going to put it into vertex form. So y equals ax minus p squared plus q. So we know our vertex to be -1 and 0.5. So that means our p is -1 and our q is 0.5, because that is our vertex. Now we need to choose a point because we need to determine a. So just like we did before with factored form, we choose the point. So let's use the point -1.5 and 0. So our x can be -1.5 and our y can be 0. Now we're going to plug it all into the equation. So y0 is equal to a, x is -1.5, minus p, which is -1, plus q, which is 0.5. When you type this all into your calculator for the brackets, you should get 0.25 times a. We're going to subtract 0.5 to each side, so we have -0.5 is equal to 0.25a. When we divide by 0.25, we get a to be -2. Now we just plug it all into the equation, so y equals -2, x minus a minus is +1 squared plus 0.5. So the fact that we got a -2, and this is the same graph we used in factored form, means we did it right. So it's just a little bit way to display the information, but still the same process. A soccer ball is kicked from the ground. After 2 seconds, the ball reaches a maximum height of 20 meters. It lands on the ground at 4 seconds. So we want to find a model for this kick. So let's just draw a quick sketch. So it kicks the ball, hits the ground. This is our soccer ball. Yeah, looks like a cookie. So the height is our vertex, and it happens after 2 seconds. So 2 seconds, and it's 20 meters high. And we know it hits the ground at 4 seconds. So we know 2 points. We know 2 and 20, 4 and 0, and also 0 and 0. It starts at 0 and it's on the ground. So what we're going to do, we know our p is equal to 2, our q is equal to 20, and we're going to use this point right here to be our x. So x is 4, y is 0. So we're plugging it into our equation. Y equals x minus p squared plus q. So y equals a, x minus 2 squared plus q, which is 20. Now we're going to plug in our x and our y. So 0 is equal to a, 4 minus 2 squared plus 20. So we're going to minus 20 from both sides. And 4 minus 2 is 2, squared is 4. So we have 4a. Divided by 4 on both sides. So -5 is equal to a. So we're going to put that into our equation. So y equals -5, x minus 2 squared plus q. And q is 20. So b, we want to find the height of the ball after 1 second. And we also want to find where that ball will be at that same height again. So we want to plug in a 1 for x. So y equals -5 times 1 minus 2 squared plus 20. 1 minus 2 is 1, squared is 1, so 20 minus 5 is 15. So the ball at 1 second is 15 feet in the air. Now, because the axis of symmetry is at 2, and 1 is 1 second over from it, if we go 1 more second, we will hit, my drawing's not very good, we will hit 15 again. So at 3 and 15, we have a point. So after 3 seconds, the ball will be 15 meters again.